1, 2, 3.
What? Oh, do I say 4, 5, 6?
Yeah. That's the start of the show now. Us counting.
Yeah. I know
Counting yourself
numbers.
in, are you?
I know a lot of numbers.
You should do. You're one of the most important nerds in Bitcoin.
My argument is that I'm not actually that important.
Really?
The thing that I always push back on is the idea that I have some kind of power. Like I have some ability to influence Bitcoin. Wow, we've gotten started already, haven't we?
Yeah. We went right off the deep end. Okay. You don't have the individual power because of the checks and balances.
Well, because there's nothing that I can't do. There's nothing I can do that isn't fully public that everybody can see. And there's nothing I can do like other than create code that may or may not be run by somebody after some amount of time after which we make a release. Anyway, we'll get into this.
So let's set it up. Explain to people listening what you do.
Okay.
Or what you are.
Okay. Should I just intro? Have we started?
We started 5 minutes ago.
Okay. Okay. So, hi, I'm Gloria. I work on Bitcoin Core. I've been doing that for a bit more than 4 years. And I've been what's called a maintainer for almost 2 now. And that it means nothing other than I'm able to push code to the repository in which Bitcoin Core is hosted.
The live repository.
Yes. We have a GitHub where we have a repository of all of the source code in Bitcoin Core. And it's developed much like many other open source projects. And typically open source projects have a small number of people who are able to have write access so they can push code to it. And we have, in addition to kind of the GitHub permissions, we have a script that checks that there's a PGP signature on all of the commits that are pushed, all the diff that is pushed. And so this is all, I remember when I said this to you, you were like, oh, how do I find out? There is a public file called Trusted Keys, and it lists PGP keys of the 5 people whose signatures are accepted for these commits that are pushed to the repository.
So you're one of the 5?
Yes. However, another thing that I say is we have all these dependencies, right? So people they often focus on like the Bitcoin Core repository, but they don't talk about like the libsecp maintainers. So the people who can push code to the cryptography library, which is a very, very important part of how signatures are created and verified within Bitcoin validation. That's also, but I think all of this is moot because my argument is, yes, I recognize that there is like an amount of privileges with being able to push code, of course. But there is nothing we can do that isn't fully publicly verifiable. And like there are so many steps between us pushing code and it being eventually run on the network by a node operator and maybe like becoming a widely used thing on the network. So like that's my argument.
Have you the new Star Wars where the Council of Jedis? Have you ever seen that?
No,
they
I
all sat around.
Sorry.
That's what I'm going to show you a photo afterwards. I think of you and the maintainers as like the Council of Jedis sat there lording over our Bitcoin network.
I think we understand the code very well, and we've spent a lot of time thinking about the security issues, and maybe we know things about what bugs have been found and how they've been patched. But like all of this is public.
Okay, can you push something live on your own, or do all 5 of you have to agree?
So we don't do it as like a committee style.
Okay.
So yes, I can push without like asking the other ones for permission. However, like we can play out the scenario in which I've pushed something that everybody disagrees with. what would happen is it would be reverted pretty much immediately. And I mean, depending on how crazy it was, like they can also remove my key. And this would all happen usually a very long time before the software is actually released and put out in the public for people to download. Of course, it's there, and if someone wants to download it, they can. But like what has happened in the past is we've had situations where a maintainer has done something very crazy, and they were it was Gavin a long time ago, right?
Yes, of course.
And so like people are always worried about like, oh, what happens if a maintainer unilaterally merges like a consensus change or something? That doesn't mean that the soft fork has gone live on the network immediately, right? There are so many steps between code being pushed, code being released, code being downloaded by individuals on the network, then becoming active, and yeah, so to answer your question, yes, I can, but like there are, like you said, checks and balances or many reasons why that doesn't mean that I have any kind of unilateral power or anything.
So if you were being sneaky and the rest of the Council of Jedis were all asleep and you push something crazy live, there's plenty of other people out there who will be checking the code and verifying it. And then typically this would become some kind of drama on social media. Gloria's gone crazy. She's done this crazy shit.
Yeah.
And then people wouldn't download it. They're like, don't download it.
Yeah. And this has happened in the past, right? So like, I'm not just like theorizing like this fantasy world. We have this very robust open source kind of community that verifies everything. So that's my point.
Did you study computer science?
I did, yeah. I went to school for computer science in Berkeley. And it was great. I loved it there. And I think it was a great foundation. And that's where I found Bitcoin. So I don't know if
Hold on, you told me about this when we were in
Malawi?
Yeah, you told me about a conversation with your parents.
Oh, yeah. I think... So I've been doing this... What was this? This was in like 2020 or so. Where I think kind of the grant programs were kind of new. Brink didn't exist yet. So I was the first grantee at Brink, which is a nonprofit that collects donations from the Bitcoin community and gives them to Bitcoin Core developers. That, was founded basically that year. And I think you interviewed John for that. But basically, when I first got started, it was kind of more status quo what tends to happen with open source. So a lot of the internet and a lot of the things that we use on a day-to-day basis are built on open source software, which like someone wrote for free and then put it on the internet under some open source license. They're like, yeah, you're free to use it, whatever. And often there's like huge things built on open source software that the person who wrote the code is not paid for, and they may or may not still be maintaining it. A lot of times they are still maintaining it. They're doing all this work to kind of support the features that users have asked for, to push in like security fixes, to like update for their dependencies, like with operating system changes or compiler changes or library updates. You also have to like keep up with those updates as a downstream project. And oftentimes that just like nobody pays for because, I guess our culture is not really about it. We usually, I guess this is like a social commentary thing. Like we usually wait for an intermediary to step in and like exploit the producer and extract rent from the consumer. And sorry to just say that, but typically the donation model hasn't been very sustainable in the past, but that's kind of the only way to do it with like Bitcoin Core, like Bitcoin open source protocol stuff.
But you could have gone to Google, got a $500,000 salary, share options, had a brand new Tesla.
Yeah. So around the same time I found Bitcoin, I was applying to internships. So I ended up doing an internship with Google, and I was going to do one with Facebook, but I reneged on that. And I thought it was so cool. But I had a fantastic time at Google, to be clear. I learned a lot. I learned about like cloud, microservices architecture, Kubernetes, Terraform, whatever. And it was a great time. But like Bitcoin was like this perfect like balance between like something that was trying to solve a problem in the world that I cared about and also very, very technologically interesting. So I think like within the first few weeks that I was looking at like Bitcoin Core, I don't know, it was like, oh, there's like this, we were thinking about thread safety because it's a multi-threaded thing. And I was like, oh, I learned about that in class. I think around that time, Peter Willett had written this like mini sketch library, which is like this fancy math. And I was like, ooh, my abstract algebra class, like textbook, like comes in handy. It's like the first time I opened it since like I took the class. And there's really cool like cryptography, distributed systems, like all these things. And like Peter Will is a great example, and a lot of other people that I work with who have been coding for as long as I've been alive, or these amazing like computer scientists and engineers kind of at least the highest level of this craft that I've seen, working on this like cool open source, like censorship resistant money thing that is solving a real problem for the world. I personally think that it is a super underrated project for software engineers that more people should consider it something more attractive to work on than like Google. That was a personal decision of mine and my parents. Yeah. Sorry. I was telling you the story where my parents were like, why would you do this? What do you mean you're going to work on this? You're getting a grant from Human Rights Foundation? Like, what does that have to do with it?
Your education cost this much?
Yeah. But, like that's another angle to it is like I'm so privileged that I got this amazing computer science education. I have parents that were supportive of this decision, and now I get to work on this really cool piece of software, and I feel really, really lucky to be able to do that.
Do they understand it now?
I've done like the flip chart. Sometimes when I go home and I see like the flip charts that I was in the garage where it's like intro to Bitcoin, and I'm like, they get it a bit more now. My mom, who like trades their retirement account, is like buying Bitcoin ETFs.
Cool.
And stuff.
I mean, it's a start. But you but mom, you're not holding the actual asset. You can be rogued.
Yeah, so I have some opinions about this where I think, like ideologically, why we're getting into this, aren't we? Ideologically, self-custody is like, that's the point, right? I think the average person, though, is probably less good at self-custody.
Listen, if you met my dad, my dad's got so much interest in Bitcoin because of me, but all he does is check the price every day, and he's like, "Beat is up, beat is down."
Yeah.
If he tried to buy and self-custody Bitcoin, he'd lose that.
Yeah.
No chance.
Yeah. So I'm really hesitant to like make recommendations to people that require quite a bit of technological literacy and like paranoia. So this is not to say that I'm endorsing like, using these exchanges that may or may not be reliable, but like I'd be fair. I like, okay, I'm not like, I'm not trying to advise people to do things that are risky, especially my mom.
How unique is Bitcoin in terms of computer engineering?
Oh, yeah. So I was just explaining this the other day to a lot of software engineers. I guess I would word it differently. But there's this crazy security model. So Bitcoin is kind of designed to work in the presence of adversaries, right?
Yeah.
Like Twitter has their own lingo to describe this nation, it's a hard, and it's supposed to be able to like continue to produce blocks, continue to process payments, et cetera, even if people are attacking it. And the software that we write is supposed to be like, we're trying to go for decentralization, right? That's like a ideological, like that's how the network brings the value that it has, is that it's a decentralized network that is run by lots of different entities and organizations, right? But what that looks like in practice from a code writing standpoint means that like I write code that is hopefully usable by anybody, right? So like we support like so many platforms, Windows, Mac, Linux, whatever. We, in terms of computational complexity, like we don't want to only write code that can be run on like AWS servers or like huge beefy thing. Like it should be runnable as like a background task on your laptop. A lot of people run their full nodes that way. It should work on a Raspberry Pi. I think that's a very good benchmark where you can run a full node that relays transactions, can do fee estimation, can, do all these like things for you on this tiny little Raspberry Pi box, which a lot of people who are Bitcoin users do. But those two things are really difficult to balance. And so like we're in this very narrow space of operation where anyone should be able to run this. But then when you turn on Bitcoin D on your laptop or whatever, what it's doing is it's connecting to randos on the network. We don't know what their identity is by design, right? We want it to be an anonymous or pseudonymous network. And it like tries to download data. It tries to find the main chain. It tries to download blocks or like find out about new transactions or addresses of nodes to connect to, et cetera. And that's what that means is we have to plan for like a random attacker connecting to nodes and sending you like garbage data that like, for example, can crash your node or cause your node to stall or cause your node to run out of memory. And these are all attacks that we would consider like one of the highest severity. And I bring this up because basically, people always ask me, like, what is there still to do? Or, like, what do you work on? Like, isn't the code finished?
Just ossify it.
Yeah. And I tried to give this message of, like, there's a lot of, like, things that can go wrong, right? People are like, but 51% attacks are not economically viable, and it's impossible to get a private key from a public key. Like, Gloria, you didn't watch this Andreas Antonopoulos video where he explained why Bitcoin is secure. I was like, yes, I agree. Like, I'm talking about, like, there's like a million ways that, like, we all envision, like, this future for Bitcoin where we want it to be used by, like, millions of people and all these things. There are a lot of things that can undermine that, including, for example, the networking attacks that I was talking about. So if somebody is able to crash nodes, or like for a miner, for example, is able to crash the other miners and they get head start on like the next few blocks, or let's say we care a lot about block censorship attacks. So like you produce a block, if somebody can prevent everybody else from hearing about that block or downloading that block from you, that is a really serious problem. Or if you've heard of eclipse attacks, where, again, like the whole point is we have this peer-to-peer structure where everyone can talk to whoever and like hopefully find a good set of peers that is able to tell them about the main chain. If that is compromised and like somebody's able to eclipse you, as in like be everyone that you're connected to, and you don't hear about the main chain or you don't hear about the competing miners like blocks, these are all really like, they're not the same thing as, if a miner is able to do this, that's like, you don't need 51% hash rate in order to attack these people, right? Like you just block them from hearing about all the other hash rates.
But are these theoretical attacks?
These are theoretical attacks, just to be clear.
So if it's a theoretical attack, do you try and attempt to do the attack so you know how to defend against it?
Well, in practice, what we're often doing is we're like analyzing the code and we're writing tests. We're trying to isolate the block download logic to just throw random stuff, test as much as possible, like all the scenarios that we can possibly happen. And, we have lots of monitoring nodes where we're seeing like, if we observe, oh, wow, there is actually someone trying to send us mutated blocks, or there's someone trying to stall block download by like being the first guy and then like sending us garbage. And then like when we ask them for, the correct information, they just like, stall. There are like theoretical attacks, and then there's also like we'll observe people doing weird stuff. And that will sometimes lead us to go and tweak those parameters or be like, oh yeah, maybe we should, we should redesign this a little bit so that we're making a better trade-off. So for like, sorry if I'm rambling, by the way.
Go.
So with, I think a lot about transaction relay. There was one a couple years ago that was transaction stalling, where let's say, there's a transaction being broadcast. Most people know about it. I don't want to download that transaction multiple times. I only need to download it once, right? So we have these kind of bandwidth saving things. Again, bandwidth saving is important because not everybody has extremely high Wi-Fi speeds, right? We want it to be accessible to run a node. So we're trying to save bandwidth by only downloading once. So we're only going to ask one peer at a time to send us that transaction. However, if we try the first peer, and they don't send it to us, we should try again, right? Or we should and we shouldn't only try 2 times, for example, because we don't want there to be a censorship vector where a peer is like, okay, I'll be the first 3 people that you asked for this transaction from, and then all of a sudden you're not going to hear about this transaction. That would be a transaction relay censorship problem. And so, yeah, there was kind of a TX request kind of reconsideration, it was like modularization plus fixing up some of those things to make it more robust and make it really easy to reason about, and then added a bunch of tests to kind of check our understanding of like, oh, in all these scenarios, yes, we would end up downloading that transaction. And then we have we've been using fuzzing a lot. I don't know if you've heard of fuzzing. Should I ramble more?
Ramble more. Tell me about fuzzing.
So typically the way that a software engineer might write tests is, for example, you'll write the test scenario that I just described, right? Where you're like, okay, let's spin up a node, like a fake node, and then we'll spin up a few extra fake nodes to connect to it, and then we'll simulate the attack and we'll assert that like the correct behavior is happening. And so you have to provide exactly what the test is. Fuzzing automatically generates tests. So what you'll do is you'll write kind of more of a skeleton, and like, it'll check invariants. Like, after each after each period of time, you check that all the invariants are still true, whatever those may be. And then a fuzzing engine will kind of intelligently just like, it'll start by like sending random stuff, right? And then it'll figure out based on, for example, coverage of the code. Like it'll look at what lines of code you've hit. And if they're like, oh, these inputs like hit like a line of code deeper into the module, okay, like we're going to create more inputs that look like that. And so it's similar to like creating random inputs, but it is somewhat intelligent, and it'll like over time just like find the paths that you maybe wouldn't have thought of if you were just manually writing the test. So we use this all the time. Now like we're like fuzz everything. Fuzz everything. And like the amount of fuzz coverage over the source code has increased like dramatically over the past few years. And it's found like pretty severe bugs. It's helped design certain things as well. When you're like trying to test the computational complexity, and you're like, okay, like let's like fuzz it and see kind of what the average runtime of it is. Or we'll fuzz it and we'll see if the fuzzer can come up with an input that causes it to spin like for a really, really long time. And we're like, okay, like instead of just theoretically analyzing what's the worst case runtime of this algorithm, like maybe have we missed something, or like what does that actually look like, or like can we add an extra piece of logic in there that like catches these really like worst case behaviors, or like it helps design things, it helps test things. Fuzzing's great.
I think most people, especially like me, when we think about Bitcoin development, we tend to think of just scaling. How are you going to scale? What's the new? What are the new features come in? I don't think many of us tend to think about how much work's done, planning for adversarial attacks or efficiency. And how is that kind of work split up amongst core developers? Is it someone specifically is working on attacks, someone's on efficiencies? Do you tend to have like specialists in each area?
So there's no kind of coordination or management, of course, but there are people who specialize. So I'm just going to shill my colleague Nicholas, who works with me at Brink. He's the fuzzing guy, and he's kind of become our security engineer as well, because naturally he becomes the guy that finds all the bugs. And he's great. My other colleague, Michael Ford, who I think you've met, or Fanquake, he specializes in build system stuff, and that also naturally leads him to do a lot of the release process stuff. And we can talk about the release process as well, because I find it very interesting. And then people will call me like the mempool person. I'm not the only person that works in mempool, definitely. But like, I spent a lot of time in this area, and typically if somebody opens a mempool PR and you ask me to review it, I will, right? Ava Chow, she works on wallet. But I mean, everyone does a bit of everything, I think. And it would be very boring to spend all of your time doing one thing. But I think there are, we've naturally been like, okay, this person's really good at this, and, has the most expertise. And I think part of our job is to just know how stuff works. I think that's really important because everything is so complex and it's so like security oriented.
But it's so interesting that without coordination, everything just kind of gets done. Do you know what I mean? Like, but what I'm saying is Bitcoin works. There are people constantly upgrading, fixing things, patching things, working on new ideas. The fact that it happens because in a decentralized, uncoordinated way, because if you think of I've never worked in a software business, but I'm pretty sure Google wouldn't have it. You just pick what you want to work on, and when you're ready, just upload it, and we'll check it. And they would be entirely coordinated.
Yeah. I think I would just say that a lot of the people that work on Bitcoin Core are so like altruistic and want to be useful, and like. I agree. There is a little bit of like, oh, you do whatever you want, and therefore, like, nobody wants to review backport. Like, nobody wants to do the boring stuff.
What's the boring stuff?
Like release process. I guess I said backport, so I might as well get into it. So as part of maintenance, right, we'll release something, and then that has like 2 years before we stop maintaining it. So every 6 months, more or less, we'll release a new major version of the software. And that'll have new features like V2 transport or, package relay or whatever. And then 6 months later, we'll release a new one, right? But the one that we released before, we're still pushing security updates to. So we'll push out minor releases. And so basically anything that, like, usually a bug fix will get merged into master, our development branch, and then we'll backport that to the branch that contains a release that's currently out. And then we'll cut another minor release. Anyway, this thing where you're just reviewing the same shit but on like a different branch is incredibly boring, and most people don't do it. And the process of picking that, the process of choosing which bug fixes to backport as well is like something that takes a lot of work, because you basically have to have a bird's eye view of every single thing that's happening, like that's being merged to like these hundreds of PRs. You have to decide, like, oh yeah, that's something that would affect like a previous release. And then, all you do is like you cherry pick it onto the older branch, and like nobody wants to do this. And the end effect is like, yeah, that thing that we released before, it still works.
Hold on, so is each branch a version?
Yes, yeah.
And so if you're not updating your node software, you eventually have things that aren't supported.
Yes, yeah.
Because wasn't there that crazy Romanian dude who refused to go anything beyond the original version 1 of Bitcoin?
So I think I heard something like that. And I think there's people who run like 0.2 16 or whatever. And like people who say like, well, let's say theoretically, right? Like it's a soft fork, so I don't need to update to the new rules and I should still be able to use, but that's ideologically a very important thing to us. And I would say, unfortunately, the consensus engine is intertwined with all of the other pieces of Bitcoin Core, like what it does. And so you aren't really able to be like, I want the modern version with, the modern wallet UI and all those things, but I don't want to upgrade my consensus engine. I think it is not good that these are kind of intertwined, and we have a project that we've been working on for years and years to kind of modularize what we call the kernel or the consensus engine, so that, like, for example, you could get the new GUI feature, the new wallet features, or the new kind of more front-facing, like not consensus, not protocol changes without, changing kernel. So my point is, don't run unmaintained software. It contains bugs that we do know about and may or may not have been disclosed already. So they're like, it's public knowledge that like someone can send you X and then you might run out of memory, or someone might crash your node or something. I very much do not recommend running unmaintained software.
and so does the entirety of Bitcoin work from in core? Or if you're a Bitcoin user, you download core, is it referencing other software or things that exist outside of core?
Yeah, so we this came up a lot with the recent like XE utils like catastrophic bug. So yeah, we do have a few dependencies, and we're like very, very, very conservative about it. And one of the things, again, like that Michael does as part of build system, he's also very about like reducing the amount of dependencies. And so like what, for example, Michael has found over the time is like, he's like, oh, we have the dependency and nobody's maintaining it. Or like they're just like, yeah, they're not maintaining it basically. Or like it's not reviewed to the same standard that we would expect Bitcoin Core code to be reviewed to. And all that code is like, you should treat it as the equivalent of your code.
But where would that dependency sit?
It would be another open source library on GitHub. Yeah.
But would that be a centralizing force?
So like when I say it's an open source, like centralizing force as in if they deleted it or something. So we would just have a copy of it, right? Okay. And we would just use our own. And we have done that.
Would you want everything just in core? So there's no external dependencies, or is that not possible?
Sorry, I get it. So dependencies wise, first of all, I was talking about like other code that gets pulled in when you build Bitcoin.
No,
but of course, yeah.
When it's operating.
It like operating systems, like you need an operating system in order to run Bitcoin.
I mean, like once you've downloaded core, for it to work, does it ever have to refer live to other systems, or does it work completely on its own?
Oh, you load like a C library when you run it. But I guess it's hard to, what are we talking about here? Like, what do you mean by refer to other systems?
Like, are there other software protocols that it relies on, or is everything within core?
Well, it needs internet.
Yeah.
Stuff like that.
I'm on about like,
sorry.
I'm probably not explaining myself well. I'm on about, you have to maintain like another protocol that's held on a server, AWS somewhere, that has to refer to for things.
Oh, I'd say there is an example of that in the DNS seeds. So when you start up your node, how do you know who to connect to? How do you know addresses? We can't put that directly. Well, we have a little bit of that directly in source code, but usually that changes day to day, right? So you will talk to some DNS seeders. There's, I want to say between 5, I think there's 8 of them, 5 to 10 of them that are run by various people. And they'll be like, oh yeah, I've been scraping the Bitcoin network for addresses, and here's a list of addresses that are very diverse. They represent various networks in the world or whatever. And then here's 50 of them or whatever, and you'll talk to 8 of these, and then you'll start connecting. So that is an example of a live thing that you're connecting to. But I would say there's very little of that compared to most things that you might think of.
When you spin up your node for your first time and it's trying to find other nodes to talk to, is there a limit? It's like you only need to be connected to 5 or 6, and once is that like that's enough to create the network effect, or can it connect to all of them? How does that kind of stuff work?
Well,
I don't know any of this shit.
So there's a couple design goals here, right? One is like bandwidth, right? You can't connect to every single person. That just, first of all, you'll probably, like, your computer probably can't handle it. And also it's just not feasible.
Because they're maintaining a constant communication.
Well, there's like tens of thousands, right?
Yeah.
I'm pretty sure you have a limited number of slots, essentially, that you could connections that your computer could be making. I'm trying to make it easy to understand. Like, it's just not like, it's not going to be feasible to connect to, like, let's say 30,000 like nodes, right? But the other design goal is like, you definitely really, really want to find, first of all, honest peers, as in peers that are going to tell you about the main chain as soon as they know about it, so that you can find the most proof of work chain, right? So like, we understand proof of work, consensus, right? Like, you find the chain that has the most proof of work on it, and that's your idea of what the chain is. But you have to hear about it. So yeah, what nodes will typically try to do is maintain like 8 to 10, let's just say 8 to 10 like outbound peers that you connected to, and are hopefully diverse and hopefully very responsive and telling you about main chain. So we'll collect statistics about everyone that we're connected to. Be like, when's the last time they sent me a block? When's the last time they sent me a transaction that was valid? How fast do they pong when I send them a ping? Like, all of these metrics we use to assess like how good our peers are. And then when we're managing all of the addresses of the nodes that we know about, we'll also try to go for diversity, right? So it's very easy, for example, for someone to spin up a bunch of IP addresses from like one ISP or whatever. But it's much harder to do that across like a lot of different ISPs. So that's why, like, we have all these ways of managing ways for us to make sure that we are connected to a healthy set of peers. And so, we'll like regularly monitor, like we'll regularly try, like, okay, let's just like pick a random one from our address book and like see if that peer is going to respond to us. And like, if we have like one of our peers has not sent us anything for, days, hopefully not at that point, is a shitty peer, like, we'll evict them and we'll try a new one. And so, there's so much that goes into the software that is not just, what's the most proof of work chain, or like, is this signature valid? And it's very complex, and it's very interesting. It's very, very interesting, I think. Like, I didn't know about this when I was taking a networking class in college, in uni. And it's cool.
And what are they sharing with each other? Is the primary information being shared to make the network work transactions and blocks?
Well, I would say it's like primarily transactions, blocks, and addresses of nodes.
Okay.
Well, there's
because I think there's a lot of people. Most people probably have no idea how Bitcoin works. Yeah, because a lot of people don't even download a node. It's a very small percentage of people will operate a node.
Everybody run a node. You'll learn so much about Bitcoin, and it's so fun, and it's so easy. It is so easy to run a node.
We're not all mega brained like you.
Yeah, you don't even need like 600 gigabytes. Everybody, like, this is a myth. Is like a very common myth that people think you need 600 gigabytes to store the blockchain. You only need to store the EJX set, right? Like, you don't need that much. You can run it on your laptop.
But the primary thing is addresses, transactions and blocks.
Yeah.
And so when a transaction is created, that is relayed across the whole network.
Yes.
Can there ever be a time when my node just doesn't pick up that transaction? Or will it eventually get that transaction?
So we're talking about transactions that haven't been mined in a block yet, correct? Yeah. So this is like what I love talking about the most.
Mempool.
Yeah. So the question was, are you guaranteed to hear about a transaction? Absolutely not. And some things that basically the projects that I work on, a lot of them kind of center around transaction censorship on various different levels. So I kind of described a peer-to-peer example, but there's also mempool examples. And there's also like, don't design your things in a way that, it can get sniped or whatever. It can happen in mempools as well. But the goal is like we're trying to build a censorship-resistant payment network where anyone can pay each other and nobody can block that. I think this is like top 3 best things about Bitcoin or things that we should strive for in Bitcoin. And so, you aren't guaranteed. So should I talk about like mempool stuff at all? Okay.
Yeah, and so look, if I don't pick it up, it's not so important. But it's important, obviously, every miner who's constructing blocks sees every transaction. But are there chances that a miner might not see a transaction? Should the mempool be the same? Should everybody have the same mempool?
Thank you for asking that question. This has been a topic that a lot of people talk about. Obviously, Bitcoin could function if... so there was a lot that was said to kind of teach everyone that not everybody might have the same mempool. There's no such thing as the mempool, right? There's each node on the network has their own mempool, and they may or may not be the same. I think when things are working really well, hopefully everyone does, and I'll explain why. We have this decentralized transaction relay network. Each node has a mempool.
Should we explain what the mempool is?
Okay, sure.
Yeah, because we've got new listeners coming in. They're like, what the fuck you want to... They're probably actually, if they've got this far, well done. They're probably thinking, what are you two talking about? What's Gloria talking about?
Okay, yeah, sorry. So let's start from the beginning. We want censorship-resistant payments. The way that we achieve that is through the decentralized structure of the network, right? We don't just have, the miner has like a website that you submit payments to. That would not be or the government has a website or a bank, right? That's obviously that doesn't, hopefully everybody understands that. That's not how that works. So what we have is decentralized network instead. You connect to one of the tens of thousands or hundreds of thousands of nodes. You send your peers your transaction and they gossip it, and eventually it gets to everybody. That's how it's supposed to work. How we implement that in practice is each node, first of all, is down to hear about transactions and validate them, and we'll put them into their memory pool or mempool. And that's just a cache of unconfirmed transactions. It's just a cache.
Can you spam that cache? And therefore, there you go.
Good question. And okay. Yeah, so you as a node operator, why do you do this? One is so that you can cache everything for when blocks come. One of the reasons is so that block relay works. So when you receive a block, what might happen if you didn't see any transactions before is you have this huge networks bandwidth spike where you're downloading the full block, and then you're spinning. You're loading UTXOs from disk, and you're doing the computationally heavy thing of verifying all the signatures, et cetera. It's very computationally expensive, and it might take you a while to do this. So that's one possible reality. And the other possible reality is yep, I already downloaded all these transactions, already verified them. I have a cache where I cached all the signatures that I checked. I already loaded all the UTXOs into memory, and I'm done. And I store it onto the next block, right? And that is a much, much healthier, first of all, situation for you as the node operator, but also for the network, because every single hop is so much faster. So block latency goes from this to this because each hop, it multiplies at each hop, right? And so the healthiest network, the ones with the least reorgs, where like reorgs are bad because, so for example, you want block latency to be very, very fast, because if two people find the next block at around the same time, hopefully everybody hears about one like quickly. Otherwise, you might end up with, half the network knows about this block and the other half knows about this block. And then at some point, you have to resolve that reorg. The fewer of those you have, the better. Right?
How often do they happen?
I think like once a week or something.
Oh, so it's still quite regular.
I don't know if every 1,000 blocks or something.
Yeah.
But it used to be more frequent. And every time that happens, like every time there's a reorg, like it's messy. It means your confirmed payment may or may not still be confirmed. Like it's a UI issue. It's like it's a usability issue. Yeah, right?
Yeah.
So it's a security issue. It can be at least. And so we really want to minimize that as much as possible. So anyway, we were talking about why mempools and transaction relay are useful for block relay. And the other use is obviously so that we can have a nice censorship-resistant payment system. And when we are participating in transaction relay, we don't just like validate whether the transaction is consensus valid, chuck it in mempool and continue. So your question, which you asked, which was like, can you spam your mempool? There are consensus valid transactions that can take you several minutes to validate, right? And they may or may not be a valid transaction, right? Like there's this really great post, I think, by Rusty Russell, which was from a long time ago, a non-SegWit transaction with like a bunch of inputs. Due to like quadratic SIG hashing, it took like several minutes to validate. But you can imagine that being like a fake transaction, right? That came in a block, which had proof of work on it. And proof of work is this like really easy way to avoid spam, because it's so much harder to produce a proof of work valid block than it is to like download it and validate it. Whereas transactions, you don't have a proof of work requirement. So it's much more like people can just send you this transaction. Maybe you spend minutes validating it, and then it turns out to be invalid. It's completely useless. It's not even going to be confirmed, right?
Yeah, thanks.
Thanks, right? And so we have rules where we're like, okay, we don't take really large transactions. Like that's a very simple rule. So consensus rule, you could have like a 400,000 like weight unit like transaction, but we make that 100,000 in transaction relay. Another really good example is we want our mempool, it's a cache, right? We want it to be useful. And so we use a lot of incentive compatibility metrics to assess whether or not this transaction is useful. So the best example is if you get two transactions that conflict with each other, they spend the same UTXO, they're double spends, you should probably pick the one that's higher fee rate, because that is more incentive compatible for a miner to mine. Even if you're not a miner, you're expecting to use this for when you're validating blocks. You're like, okay, this is more likely to be mined, and therefore I'm going to take it. So that's another example of like what we do in transaction validation. And that's what leads to being able to RBF, to replace by fee, right? To fee bump that way. Sorry, I'm getting to your question about should everybody have the same mempool? Hopefully,
in an ideal world.
Yeah, in an ideal world, things work best if everybody has the same mempool. Of course, like all these rules that I described, they're not consensus. So you can have whatever you want, right? Like, let's say you're like, the example is like, I hate inscriptions. Or like, my mempool like doesn't allow spending unconfirmed UTXOs, or you can do whatever you want, and that that's allowed. But like people are like, therefore everybody should have different mempools. It's like, well, no, that's not where we were going. But I think it was like kind of this overcorrection of like people used to think there was the mempool that you would submit transactions to. And then now everybody is learning, oh, actually everybody has their own mempool. All the mempools should be different. Well, no.
I used to think that. I did. I used to think there was just like one mempool. That's why I asked the question, are there out side dependencies, because I imagine there was this mempool of transactions. I didn't realize the transactions themselves were getting relayed and stored. So when we go to the mempool website, is
mempool
that
space.
is that just their own?
Yeah. That's so mempool space and mempool are different things.
Yeah.
There's like mempool, the memory pool that each node has.
Yeah,
and then mempool space happens.
And so that's just theoretical. That's just what it should be.
I think not necessarily.
Where did they take theirs from?
So they they run their own Bitcoin nodes.
Yeah, that's what my assumption is. But therefore, theirs could theoretically be different from mine.
Yes, absolutely. So I think they run a few different nodes, first of all. And so they have like a huge node that has like all the transactions. And then they have like the default node, right, which is 300 megabytes. And so like when fee rates are really, there's like a ton of transactions, like the huge mempool will have all of them. But for example, your 300 megabyte mempool is going to start purging the lower fee rate stuff that is less likely to get mined. We're using incentive compatibility to assess what to
So when they get
away.
purged, where do they go to?
You just throw them away. They're gone.
From my node?
For your node, we'll just throw them away.
But a miner would never throw any away because at some point they might mine them?
I would imagine that they do something very similar to what mempool space does, which is they have a huge node that just keeps track of all of them, but they have like a default node. Because the larger your mempool, the more computationally expensive everything gets. Like building a new block template, for example. You want to do that on a smaller mempool.
So the huge one is just for storing all the stuff later. It's like, okay, if we go through a very intensive period where there's lots of low value transactions, they park them for later, and then fee rates drop, then they'll bring those in.
Yeah, exactly.
So much today.
Yeah, exactly. And so I think part of like mempool space has this cool audit feature, right, where they build their own block template and they compare it to what got mined, and you can see like, oh, are they, it's not always censorship. Like there's many reasons why the transactions might be different, but like you can kind of see what it would be, or like what the difference was. But of course, like your node might be different from mempool space's node, and that might be different from the miner node or whatever. And so it's like very difficult to prescribe a reason why a transaction might be different.
Could I ever post a transaction where the fee's too low and it never get mined and it just sits there and lost forever?
Well, if like everybody's bidding higher than you for block space, then sorry, you got.
But does that transaction eventually just get cancelled? Can I?
Ooh.
Do I have to somehow cancel it myself? Do I bring it back? Like, how does that work?
So I don't think you can cancel it. I think once you've signed that transaction, so for example, a miner could just be logging every single transaction that they see. And then like 6 months later, you thought it was canceled. And maybe you were like paying your friend or a merchant or something. And you're like, okay, I'll just send you a new transaction. That one's canceled. Like it might get mined.
How do you bring it back? Is there any way you can bring it back?
No, sorry. There isn't. You could double spend it, right?
Okay.
It's still not guaranteed that someone might not mine it, right? It's a consensus valid transaction. You've already broadcast it.
Can I increase the fee?
Yeah. So you could like I described before, you could create an RBF where you double spend it in a higher fee rate transaction. And theoretically, a miner should mine the higher fee rate one. But again, they could decide if they wanted to, if they're being weird, like they didn't hear about, for some reason they didn't hear about the fee bump, or by the time you fee bumped it, they had already started working on a block with that transaction in it, for example. These are all potential reasons why like your RBF may or may not get in, may or may not happen. There's a lot of reasons why the replaced by fee transaction may or may not work. One of those, like some of those reasons, because I've spent a lot of time looking at kind of the limitations of RBF, is just like our policy rules are not very smart. So we make a trade-off again between being resistant to denial of service, like trying to be computationally not complex, as well as incentive compatibility, right? So Sometimes we make a trade-off where we take a shortcut or we have an imperfect heuristic for assessing incentive compatibility because the actual thing would be too computationally complex to do. And so we might look at two transactions and we'll be like, oh, this one's better to mine, but actually this one is. And so we might reject a replacement that's actually better, or we might accept a replacement that's not better. And like this is, I consider a bug. It's a very complicated bug because it's the result of kind of a lot of engineering, and these are very like kind of edge cases. But yeah, I've spent a lot of time essentially working on these kinds of replace by fee policy limitations, and we have a few I have some proposals as well as other people have. I don't speak on behalf of anyone other than myself. There are a lot of really exciting projects that people are working on to try to fix these things in mempool.
So how has inscriptions changed the mempool game? Because clearly it has.
So I remember we had like a 3-round trip debate where I think it was around, like, people were really upset that the fees were so high because of all the, I think, BRC 20 stuff.
Yes.
And they were like, can you fix this? And I was like, you're kind of like somebody who's driving down the highway and there's traffic and you're like, road workers, why did you allow all these people on? Like, it's like, yeah, other people are allowed to send Bitcoin transactions. And the way that they're chosen for confirmation is based on fee rate because miners are, economically incentivized to include those transactions. They use the blocks. Yeah. I mean, they use the scarce block space to a demand that's very high. And it's using economic, right? Like the price goes up for a unit of block space, which is the resource that you're trying to consume.
But this stuff is political.
Yeah, it's
and do you feel like as a developer or a maintainer, either or, do you feel like you have a duty to not be political, not have an opinion, as long as your job is just to make sure the software works?
Yeah, so the issue that I had when we were talking about this was that people are like, can you stop the spam? And spam has a very specific, like we've just been talking about the definition of spam when we're talking about mempool code and transaction relay code, where, it's using a resource, for example, your computer's, computation or memory, that it shouldn't be. And we have all kinds of ways of preventing that. And so I have a definition of spam that I use when I'm thinking about this kind of code. And people are asking me to apply that definition based on use case. And I don't think it's the protocol developer, the transaction relay code's place to decide what use case is legitimate or not. You know what I'm saying?
It can happen at a node or even minor level like Ocean have done. That's where you can make that decision, because in a decentralized network, you get to decide yourself. Yeah, if you don't like cat photos, you don't like wizards or whatever, that's like your choice, right? But I don't think this is not a legitimate transaction, or, this is a waste of blocks, because NFTs are bad or whatever. I don't think that language has a place. Well, I don't think that should be considered when you are talking about writing policy code. Yeah, as a developer. As a developer, as a protocol maintainer, like. It's been such a tricky subject to navigate. And honestly, I've gone back and forth on this. I've ultimately come to the point that my preference would be Bitcoin was just used for financial transactions. Sure. Of Bitcoin being money. And I know someone will say, well, these still are. But I don't like the idea of censorship. But I had a very long conversation with Bitcoin Mechanic. Obviously, he's very much involved in Ocean. I agree with him. Like the thing I care about, the thing I'm here for is the improvement of money, especially with the kind of things we saw out in Malawi and Kenya and Ghana.
Yeah.
I have zero interest in quantum cats. I feel like some of this stuff's an attack on Bitcoin. But I've come to really appreciate that it puts you in a difficult position because people want you to have a political view. Do you feel that as a pressure?
Yes.
Yes,
Well, I don't know if people are asking me to have a view so much as they're demanding that we change the software and right.
Yeah.
And I think to be kind of fair to this argument, we've identified a couple of reasons why you would have policy as in the validation rules in mempool that aren't consensus. And historically, there have been kind of things put in place to discourage things that are bad for network resources. So for example, we have standard output types and we have a dust limit. And that's to try to discourage creating a lot of, and even the witness discount as well, is kind of to try to discourage bloating of the UTXO set.
What is a witness discount?
Oh no, we're getting into it. Okay, so let me just finish that idea first. So I talked about how you can run a fully validating Bitcoin node and you don't need to store the entire blockchain. You just need to store the UTXO set, all of the UTXOs, and that is enough for you to validate whether each transaction and each block is valid. Well, you also need the headers chain. You don't need all, you're right, you can prune most of it. And so the size of UTXO set is kind of very important to scaling and to the accessibility of running a node and all those things. And so, what were we saying? Oh, witness discount. So when we are looking at the size of a transaction, certain parts of the transaction are weighted differently from others. And so the witness data, which is like the signatures or the scripts that make this transaction valid, which can be discarded, that is weighted less. That's all the witness discount is. And so that means that if you make a large witness, that won't cost you as much in fees, for example, as if you like made a lot of outputs, and outputs are what go into the UTXO set. And similarly, like we have a list of like standard output types. So that's pay to witness pub key hash, or pay to taproot, or pay to witness script hash, or those like standard types. And they're very small and they have a standard format. And say okay, we don't have to get into the dust limit, but there are like various.
What is the dust
rules.
limit though? Like, okay. What's the actual value?
Sure. Oh, it depends on the output type. So I just described the different output types. So I don't know if I should explain what they are. But if you create an output that has like 1 Satoshi in it, well, you're not, like, if you are to spend that, it's going to cost you more in fees to spend that UTXO than it's worth. You know what I'm saying?
Unless you've got a special Satoshi. First Satoshi. On the block.
Sure.
That's bullshit, right? You can't identify individual Satoshis.
Well, that's what ordinals is, right? Yeah, like you have an external. But
they've just basically made up their own numbering system. But these Satoshis don't exist individually, because a UTXO is essentially like if I put a £20 note on the table, there aren't individual pennies in there. It's just a £20 note. You can't identify the individual pennies in that note.
Sure. I guess we can kind of.
You don't need to do that.
I think, like you can like do anything to derive meaning that isn't kind of baked into the protocol.
But ordinal theory is something that sits in an external protocol outside of Bitcoin. Yeah,
that has nothing to do. Like when people tell me to stop doing ordinals, we don't have ordinals.
Go fuck yourself.
Yeah.
So the dust limit, does that have to be a kind of a moving beast as Bitcoin value changes? or is it irrelevant because it's priced in Satoshis?
It's priced. It's determined based on like Satoshi units, right?
Yeah.
So if you assume that let's say you're always going to have at least 1 sat per vbyte.
Yeah.
The decimal is actually 3, but like 1 sat per vbyte on any transaction in order to spend it, then you can't be making like, if you make a 5 sat output, then like it's uneconomical to create that output because it's worth less than what it would cost to use it.
It's a bit like how in Canada they don't make the penny anymore because it costs more than a penny to make a penny.
Yeah. And so we started talking about, so we were talking about this because this has been like a very, very long-standing rule is we had these like standardness checks in policy where you can't do that. Or like if I'm running I have my mempool and I'm running my node and I receive a transaction that creates a dust output, I'm going to go ahead and reject it, even if it's consensus valid. And that was kind of there as, I guess, the idea is to protect network resources, to encourage people not to do things that are, going to hurt the scalability and whatnot. And people are like, why can't you do that for inscriptions? Because like policy can ban or like can prevent things. And so people are like, why don't we have a policy rule where if we see an inscription in a transaction, like the NFT like thing, then we also ban that in policy. And this idea has been dressed up in like many different trench coats as different pull requests to the Bitcoin Core repository. Oh, do you know about this? And like they've become like flame wars on GitHub, which is not Twitter. It's a place where you discuss code. It's
as maintainers, has this been something that's been debated, or is it very obvious that you just don't get involved in this? This is censorship to you.
So we've talked about this because I think people take pull requests seriously, right? Like anyone can contribute. It's not like we're like, like we'll take every pull request serious. When I say we, I speak on behalf of myself and not anyone else, of course. But yeah, like, you think about it. And actually I published a like really long document kind of summarizing one of the iterations of this kind of proposal because it had like hundreds of comments from various people being, to various degrees of professionalism. So I like tried very, very seriously to like index every single comment I could find on it, like summarize the arguments and weigh kind of the merits of the technical arguments against each other. So I did very seriously like review that PR. And I can send you the doc if you want. But like what we were talking, so the idea was like, why can't you do this for inscriptions, right? And like, I think there's two things. One is like, you can do this on your node, right? But like when you're asking, there's a difference between like, I want to do this on my node and I want Bitcoin Core to ship this as the default, right? And so there's two things that I really just want to put out there. One is like Bitcoin Core doesn't have the ability to just censor things, right? We can only, like I said, we try to publish software that is accessible to run, but also incentive compatible to run. If I publish, if we create a piece of software and we're like, hey, miners, can you please run this? You'll lose like 30 Bitcoins in fees, but like, please run this. They'd be like, no.
By the way, did you see those fees in the first few blocks of the halving?
Yeah, that's what I mean.
Was it like 35 Bitcoin
blocks? Yeah. Again, we just publish code. We don't push, we don't force people to run it. We can't ask people to run it. People voluntarily download the software and then decide whether or not they want to do that. So if you publish software and you're like, well, if you run this, you lose 30 Bitcoins in fees, but please, that's not how that works. And we just finished talking about how everyone has optionality and what kind of mempool rules that they're going to use, because it's not consensus again. And we have so many clear examples of Marathon or F2 Pool mining things that are that would have been rejected by the Bitcoin Core default saneness rules.
Is this the out of band stuff?
Yeah.
What is that all about? Are they constructing transactions but that don't go into the mempool? They're not broadcasting them. They're just putting them as part of a block.
So it would be in their mempool, and then they just don't send that to anybody else. Or like a lot of times they do it because they're running some patch that is different from the Bitcoin Core like rules.
Is there any danger to out of band transactions?
So let's go back to the block relay latency thing that we were talking about, where anytime you create I think when things are working right, best, like everybody already knows all the transactions by the time you broadcast that block. And then like it propagates like immediately, right?
Right. And if they construct it, so if they, a single out of band transaction is fine, but if they did a whole block of them and then broadcast that, we'd have a potential latency issue.
So actually a single one makes a difference as well.
Okay.
So kind of the way that block relay usually happens nowadays is with compact blocks. And we have like kind of direct high bandwidth, like first round, like no round trip ones as well, where basically I just send you like a skeleton of the transactions, and I have like short IDs talking about all the transactions in the block. And if you already have that in your mempool, you're like, cool, I've got it. But if you're missing something, you have to be like, hey, Gloria, can I get one of those transactions? And then I'll be like, yeah, sure, here you go. And that's an extra round trip. And so, like a single transaction can make a difference. And of course, a whole block of transactions, then it's like, oh, I have to download all these and I'm going to validate all of them. And then, and so, it does make a difference.
Is that a point of debate that should the network allow out of band transactions? And could they be stopped?
Well, no.
They could not be stopped.
No, because we know about Marathon because they offer like a service to do this, right? But there's no way for you to enforce, like, you can only give me transactions that I already heard about. It's that's why we have blocks.
Yeah,
it doesn't work that way, and. So there wouldn't be a way to because that's why we have consensus in blocks. Is we have consensus rules in blocks, and then we're like, okay, these are the orders of the transactions. If we had a way to do that if we had a way to be like, this is the order in which transactions are received and created and whatnot, then this wouldn't we wouldn't be doing all this, right?
So have inscriptions presented. All right, look, we'll agree that you shouldn't censor them. We'll agree that, that's not your job at a policy level. You want to say something?
Yeah, we can't I don't like the word censor because we don't have the ability to do that. I just said, we you know what I mean? Like we can create. No, we don't.
You have all
That's
the power.
why I started this episode. That's why I started right off the bat. I don't have the power to decide what other people's mempool policy is.
She has so much power.
We can't do that. And my other point was that it doesn't make sense.
Yeah.
We can't write software that's just just throw away. That's not incentive compatible.
But have inscriptions changed the work you do in that? Has it presented new attack vectors you have to think about?
Like the inscription transactions
themselves? I don't know. Just the fact that they exist at these BRC20, has that changed the way you have to work? Or do you just see transactions and therefore it doesn't matter?
I would say I think there's two things we can talk about. One is a bug related to just what happened with really high transaction volume. And the other one is kind of more attention to, I think Mononaut calls it mempool sniping. So I'll talk about the first one. And this is not this is not the structure of inscriptions. This has nothing to do with ordinals. It's just the high volume of transactions. This is just kind of like an anecdote. Is we discovered that there were a couple transaction relay data structures that were not as efficient as they could have been. It probably would have worked for, hundreds per minute, but it doesn't work for tens of thousands per minute. For
That's
example.
a good thing to find that out.
Yeah, exactly. And I'm not saying like,
Thanks,
oh, this
wizards.
is great, but like a lot of people are like, has anything happened? And I think this is a positive thing that came out of that. And then the other one, what was I going to talk? It was the mempool sniping stuff. I really wanted to talk about this on a podcast because it is what I have been talking about for ages. Is I was always like, okay, like so pinning is like the thing that we're going to talk about. I was always like, this is really bad. This is especially bad for like L2s and like Lightning Network kind of stuff where I'll just do a shorthand one. Basically, you have the same security model because you can always settle on chain, right? You have like all these off-chain transactions that you're not going to broadcast. And through that, you get the scalability and the privacy and the cool features. But the security is the same because you can always settle on chain. You've already enumerated all of the spending paths. And they include like, hey, if you're going to do this, I have 2 days to respond. Or, and I respond by broadcasting this transaction that spends from it. And I have 2 days to do that until the other spending path opens where you get to redeem the money, right? That's usually how those L2s are kind of set up, is you have this critical period within which you need to broadcast your transactions. And so my argument was always like, okay, but what about the games you can play in mempool where like I can try to censor your transaction through various means. So one of the things I was talking about was with like replaced by fee, RBF. Sometimes you might broadcast a replacement or you might broadcast a transaction that makes perfect sense, but because of the limitations in how the validation like code works, like it'll just be like dumb and like not realize this. Anyway. So with kind of all this like NFT stuff, like basically I would say this and people are like, but does this ever happen? And I'd be like, well, no, but like theoretically it could and you could lose money. But we actually like saw what people call like pinning.
So it happened in the wild.
Yeah, it happened in the wild because was it like ERC20 has these like anyone can like mint the coin or whatever. And then so it was like basically a race to like who can do it first, right? Or like, I think there was one where they exploited like the descendant limit thing where, actually it probably doesn't make sense for me to talk about the technical details, but like they basically exploited this limitation where we're like, oh, we're only going to consider the first this many. And then after that, like it'll just like we'll limit the topology of the transactions that you're broadcasting because we can't handle more than this much. And then so they're like, okay, I'm like, I took up all these slots and now you can't add a transaction to this. And then there was another, this is the other thing is like these like swapping things that are using anyone can pay. Have you heard of SigHash? Anyone can pay.
Yes.
Yeah. So you can sign your transaction so that other people can change it. They can add inputs and or outputs to it. And so what that meant was like in mempool, people could replace it with their own version of the transaction where like they got to buy the NFT instead of the original person who broadcast the transaction. And that one is not a limitation in mempool policy. That one was you used anyone can pay, and that's how anyone can pay works. And so there's kind of all these like people are kind of discovering this like, I think censorship is the wrong word, but like things that can go wrong between the time when you broadcast your transaction and it may or may not getting confirmed. And I think that's great that people like, I'm so annoyed when people are like, oh, mempool should fix this. And I'm like, what's happening here is people are buying stupid sports cars that don't have locks on them. And people are getting their car stolen and they're like, what's wrong with these roads? Like, why are these roads so it's like, no, put some like stop designing your thing in a way that it can be stolen. So yeah. Did that answer your questions?
Somehow. We've meandered through so much.
Yeah.
I do want to ask about ossification because it comes up. To me, in my very simple technical mind, it always sounds dumb. It's like, how can you possibly ossify? I don't even know what it means to ossify. What, we just lock the code and it can't be touched? That sounds psycho, because what if there's a critical bug? Like, my basic logic says that doesn't make any fucking sense. Why are we talking about it?
I think probably ossification means something different to many people. I agree that the one where it's like, just stop touching the code, that doesn't make any sense.
Yeah, the only ossification that makes sense to me is like a stalemate of things just don't get done because we can't get agreement to get things done.
That's also scary.
I'm talking about big, significant,
like consensus changes. Well, so there are a couple consensus changes that are kind of needed, right?
Oh, really? Because who was it? Somebody said, was it John Carvalho said there are no hard forks. He said there won't ever be a hard fork. It is just a copy. Did he say it's just like a copy of Bitcoin? Someone will always run the original Bitcoin.
Right. Yeah. Yeah.
What are the ones we need? What consensus changes do we need? Are you talking about the one that we need for like when we're all dead in like 2140 or what is it?
Like
There's
running
a bug,
out
isn't
of
there?
not running out of time for the timestamp.
Yeah.
And there's I think there's a couple bug fixes that would be nice. If you've heard of the consensus cleanup. Oh, we probably shouldn't talk about that.
Oh, why? Because why shouldn't we talk about it?
I don't
people aren't aware of it.
I try not to say things on podcasts that can be taken out of context. Like if I say like we need X soft work, right?
Bitcoin's broken.
Yeah. And sometimes things that I've said have like landed really poorly on Twitter, and that, you know, like I'm like people will think like I'm trying to say Bitcoin's broken. It's like, well, no, I wouldn't be working on Bitcoin if I didn't believe in it.
No, you can just fix it.
I don't have that power.
So how is Bitcoin broken?
Okay. That's never what I'm trying to say. What I'm always trying to say is there are, like I said, all these network level attacks, all these like scalability, like all these like ideas we have of scalability, of censorship resistance, privacy, etc. These are not like single lines of code that Satoshi wrote in the original client and then like Bitcoin has that, right? They're design goals, and like we have to fortify them over time. And like I said with the example with the transaction traffic being really high, the requirements change each time you go from like one level to the next. And nobody ever designs their software for 1 million people in the first iteration. You can build a POC. And I'm never trying to dig. People thought I was hating on Satoshi once too. Satoshi's great. I'm not saying that like the POC is bad. I'm just saying like over time, like the requirements get more stringent. And
you've literally come on my show and said Bitcoin is broken and Satoshi is a dick.
First of all, I named my dog Satoshi.
Did you?
I love Satoshi.
Charlie Shrimp named his boat Satoshi.
Yeah, well, I think I have beat on that one.
You got the dog. Okay, but there are some things at some point that need doing.
Mm-hmm.
Ultimately, though, will that 100% definitely require a hard fork?
I wouldn't. I'm not convinced. Yeah,
Okay.
I think it's like there are things where it's like, oh, we probably need a hard fork, but we can probably figure out a way to do it using a soft fork.
Yeah.
Yeah. So
because we haven't really ever had a hard fork. And we had did we have one like that was a bug fix, the inflation bug or something? I feel like I heard there was, but like we're not like Ethereum that has one every like couple of weeks or.
No, I don't think we've had like a. Well, I think maybe in the very, very early like prehistoric, Bitcoin days, but no, not. We hadn't had like
and
a
people
purposeful.
Have forked away.
We
but,
do.
Yeah.
And people have forked away.
But ossification's just just can't really happen, right?
I think it's like what's the definition of that? I can speak to kind of my personal thing that has some things in common with what people say when they ask for ossification, which is like, I think we're at the point where it's best to seek to like understand and formalize and test and document and like isolate and test the code that we have as much as possible. And I'm not really saying like we should add a bunch of features and whatnot, at least to Bitcoin Core. I think to Bitcoin Core, to like all the people who are experimenting with wallet UI and like trying out new I'm not talking about that. Like there's so many things that need to be built, so many more layers to scale. But in terms of like the protocol, I would say that I lean towards the conservative side, because there's just so much to do that just in terms of like understanding the code better and fortifying it, as I would say. And sometimes that involves a protocol change, right? Like sometimes you need to kind of like invasively change something in order to make it more scalable, or better, or for whatever reason. So it's not don't ever change the code. It's like be conservative and like not try to move fast and break things. I'd say that that's something I have in common with the people who are like ossify, but like don't touch the code, I think is quite absurd.
What do you make of this privacy stuff that's happened this week with Samurai and Wasabi?
Ooh.
I mean, it's obviously depressing. Has that spiked any interest or discussion about bringing privacy to Bitcoin at the protocol level? I know that comes with all the different complications, but is it a discussion point now?
There's a lot of privacy built into the protocol level. Do you mean?
I mean, like Monero level privacy on transactions.
So I haven't personally had a conversation about this with other people who work on Bitcoin Core. We did talk about it and how terrifying it is.
There was a tweet. Let me find this one for you, because this is where I actually think it's particularly depressing. Because I didn't think it was depressing at a personal level, because I'm a bit lazy with a lot of my privacy. But this one, Peter Van Valkenburg, she retweeted Anna Chekovich. I can't pronounce her name, but she said at the ACF, which is Anti-Corruption. Here you go. The Anti-Corruption Foundation. We relied on Wasabi when protecting our donors from Russian government surveillance and risk of imprisonment. That was not taken into consideration by the US authorities when they began attacking privacy tools. I mean, that's particularly depressing.
I think that kind of goes. I'm not an expert in regulation and the history of what money transmitters are how they're classified or whatever. I think it is really serious that like I said, like there are so many roadblocks that are on the technical level, on the regulatory level, on the marketing level, right? It's like whenever I think about like a network crash bug, I feel like a lot of it is like it'll be a PR disaster, or like it'll be really difficult to like convince people that Bitcoin's safe if like nodes crash, and also that it would be pretty bad. But yeah, I mean, so the question on how we think about privacy and I think there's a lot of that. So with the release that just came out, like V2 Transport, which is encrypted connections between peers, that's default now. And yeah, there's we support running nodes on Tor and stuff. So yeah, like privacy is often a consideration when adding new features. Oh, and Basil's working on like broadcasting your own transactions on Tor connections to try to improve transaction relay privacy that way.
There is so much to Bitcoin.
Yeah, so much. Yeah.
Do you feel like there's like large parts of Bitcoin you don't even know or understand yourself?
Oh, yeah. Yeah, definitely. Like even within Bitcoin Core, there's like, all this cryptography stuff that like, is like magic. And, it's like all the time I'm like, oh, I want to go explore this because this is really interesting. And but so much of Bitcoin is so cool. And that's kind of, I think, how a bunch of people end up working on core is like, don't trust, verify. How many people who like scream that have actually like verified the code works the way that they think it does? But that was like what I was doing, where like now when I'm around like, how does this work in Bitcoin? I'll be like trying to look at the code to like see how it works. Like that's a great feeling. But like obviously like nobody knows everything. Yeah, there's so much to Bitcoin and it's so interesting. So many interesting problems.
Is there enough developers?
No.
And is that a funding problem, or is that a whatever number you had, you still say no?
Oh, no, I think I can imagine a scenario in which I would be like, yeah, I'm feeling good about this. But a reason why I come on podcasts is like ultimately Bitcoin is like we're trying this experiment of like completely decentralized organization or governance or whatever. And at the end of the day, like you or me or any other Bitcoiner has like the same level of responsibility to, like if there was a really big bug or if, Bitcoin didn't succeed the way that we want it to, it wouldn't be because like the CTO like didn't do his job or whatever. It would be because all of us who have this responsibility didn't, do it properly. And if Bitcoin fails because everybody thinks it just, boils the oceans and has no value and, helps criminals or whatever, like that would be like everybody's fault. And you do amazing work in evangelizing Bitcoin, but that's not your job, or like that's not like it's not inherently like Bitcoin said, Peter's our CMO, right? It was like you went and did that. And just like all the people who worked on core, it's like, maybe they held Bitcoin or maybe they got nerd sniped in college and they're like, oh, I'm going to work on Bitcoin core. It's not because like the Bitcoin Core company hired you to be the CMO and, this guy to be the CTO and like Michael Saylor's the CEO or whatever. It's like we're all equal peers in this decentralized community of Bitcoin. And so, of course, naturally, like we don't have an HR department. We don't have like a thing that is responsible for making sure there's people working on the infrastructure, right? And so basically what we have to do is we have to try to like find people. And so, like Jonas Satchenko does a lot of educational programs. There's B-Trust, there's Summer of Bitcoin, there's Kala, like Brink has a fellowship program where we try to train people. And, I'll go to this is why I go to conferences so that I can meet people who I've, only seen pop up a couple times on GitHub or on IRC. And I'm like, hey, like, let's review a PR together, right? Because if I don't, like, there's no HR department, right? We're all trying to figure this out together. We all have an equal responsibility.
Doing our part.
You listening to this podcast.
Donate to Brink.
Are also, yeah. Yeah, you can also just contribute by, if you hold a certain amount of sats, like nobody's charging you to do that, but there is a cost for it to maintain.
Pay your voluntary tax.
Yeah. Like don't wait for somebody to charge rent. Don't wait for, like we all have like an equal part to play in this. And like I said, I started this podcast. I don't have any extra power. Like you can come to GitHub and open a pull request and contribute to Bitcoin Core. It's free for anybody to do so. And I would encourage you to do that.
I'm going to call this episode, Gloria Says Bitcoin is broken and Satoshi is a dick.
Yeah.
No, it was brilliant.
Okay.
I learned so much today. I always do, but I'll forget it.
Oh, man, I feel like I meandered so much.
Don't worry about it. Do you want to pimp Brink?
Oh, absolutely.
Come on.
So Brink's a nonprofit. You can make a tax-deductible donation to it, at least as a U.S. taxpayer. And Brink uses that money to fund Bitcoin Core development. We have a special focus on security. So we have maintainers like Michael Ford and me. We have Nicholas who works on the fuzzing, if you found that very interesting. We also pay for the infrastructure costs to run the machines that do the fuzzing and the testing. And we have this wonderful office where people come and work together. And we also produce the OpTech newsletter and the OpTech recap. A lot of people don't know that that's part of Brink. That money goes there too. And yeah, it's a great way to contribute. If you do not write code, you can donate to Brink instead.
Amazing. Rich Bitcoiners, put your hand in your pocket, support Brink. Gloria, this is amazing. I knew it would be.
Thank you for having me.
No, anytime.
Really
we will definitely do this again. Yeah, keep going. Thank you. Amazing.
Thank you.